Provectus, a premier AWS consultancy firm and AWS team. Let's wait for 10 more seconds for the people to join, and we'll get started. Few comments before we begin. As we move through the content, you're very welcome to ask questions in GoToWebinar chat window. We'll address them during Q&A session at the end of this presentation. We will share with you a webinar recording shortly after the webinar, so please stay tuned, and there's a bunch of useful links to be sent after the webinar. All right, here we go. Today's objectives are to learn how to build scalable and secure machine learning infrastructure on AWS and how Provectus can help you in that journey. To discuss the best practices for using AWS SageMaker and open source tools, we're going to marry two worlds of fully managed AWS tools and open source projects for the better world and better AI on our planet. And finally, we'd like to take something home after this webinar and offer a collaboration, a follow-up session deep dive into your machine learning infrastructure. So we will be able to elaborate on your pain points, ask questions, and receive feedback and recommendations for your use case from AWS and Provectus experts. We expect the audience to be familiar with AWS in general and with SageMaker in particular. It would be much easier for you to digest the following content if you are familiar with ML workflow. We also expect that you have visited at least the home page of Kubeflow and you understand on a high level the value proposition for Kubeflow pipelines. We will start with introductions, then we'll quickly show you the happy end, a case study that demonstrates the real benefits of having machine learning infrastructure thoughtfully designed and built on AWS. Then once you understand the final goal, we will dive into the implementation aspects and talk about AWS toolset, Provectus value add components for experimentation, machine learning operations, and feature store. And then finally, we'll learn about details of fully funded ML infrastructure acceleration program by Provectus. Quick introduction. We have Stepan, Provectus CTO, who is speaking at this moment. The topic of this webinar is basically describes my background in data, machine learning, DevOps, and cloud software architecture. I'm excited to co-present with Alex Chung, from a senior product manager from AWS. Alex, please chime in and introduce yourself.
Hey everybody, my name is Alex Chung. I'm one of the product managers on the SageMaker platform. I specifically handle our integrations with open source tools like Kubeflow. Before this, I was at Facebook leading our computer vision data strategy there. And before that, I was at Lyft. So I've been working on ML for quite a while now and excited to partner with the Provectus team here to share about how Kubeflow and SageMaker work together.
Awesome. We also have Q&A panelists, Rinat, Iskandar, and Ilnur, here to answer your questions. Do not hesitate to ask questions in GoToWebinar question tab as we move through the webinar content. So why am I talking about MLOps and ML infrastructure and claiming to know something? For those of you who have been in the industry for a while, it's not a new thing. AI companies were struggling with the big data environments, analytical and machine learning pipelines for a while. I have posted this high-level article at KD Nuggets almost 4 years ago, which became surprisingly very popular. I was discussing all the challenges data engineers and data scientists are facing working with on their projects. Ironically, 4 years ago, I have summarized 3 major upcoming trends as tools evolution. We needed more tools to support machine learning lifecycle and to make the life of machine learning engineer easier. Education and cross skills. It was clear that data scientists had to acquire new skills like Docker, cloud, as well as basic software engineering practices. And the process, at that time, I used the term DevOps and its application for new type of workloads. So it's great we're talking about it today. Even if we use new buzzwords, the main principles remain the same. A very quick introduction of Provectus. We're fanatical about extracting value from data through AI and deploying it to the real world. We ship end-to-end AI solutions for business, and we consult CTOs, CDOs, machine learning, and data engineering teams on how to build a foundational components like ML infrastructure. Quick facts: we're headquartered in Palo Alto, have 450 employees worldwide, and we serve clients ranging from the cutting-edge startups to large Fortune 500 enterprises. And what makes us different? We're a top-tier AWS consulting partner specialized in AI and machine learning. There are only 6 companies in the world in our category. Some of our lovely clients are listed here. We're comfortable working with big enterprises and driving multi-million transformational projects, as well as helping startups, partnering with them from the early stages through all the funding rounds and successful acquisitions in IPO. Okay, we have introduced ourselves. I think it's a good time for you to introduce, for the audience to get some feedback and introduce yourself, guys. A quick poll: what is the level of ML adoption in your company? Please select one of the following. If you're just exploring, either you're exploring, either you're doing a POC, or you're launching the first application in production, or you're kind of focusing on a foundation of the further machine learning infrastructure. Or you're already scaling many parallel initiatives and production workloads. Let's wait for 5 more seconds and move on. Okay, let's see the results. All right, pretty interesting. So I think the audience can see the results. 1/5 POC and exploring, and yeah, I'm excited to see many like 23% of us and of the attendees are scaling many parallel initiatives and workloads in production. All right, let's move on. So the best way to visualize the benefits of the solution is to look at the real-world case study. GoCheckKids is an amazing company that helps millions of kids to prevent vision impairment. A quick recap of this case study. The problem was that we've been solving is a detection of eye disease like strabismus crescent based on the images taken from iPhone application. We also had to reject images when the child was not looking properly to the camera. Security and compliance is the first priority for this type of the projects for the obvious reason. So ML problem was framed as an end-to-end image classification in this case. And so the problem may seem to be very simple, classifying cats and dogs in a nutshell. However, there is a huge difference in classifying cats for fun and deploying a real mission-critical solution to the real world and real data sets. Let's look at the modeling hypothesis we have outlined during the research phase. We played with different the input pre-processing strategies, different feature generation backbones like deep convolutional networks, mobile net, efficient net, and custom ones. We've tried many transfer learning techniques, synthetic data sets. We tweaked objective functions and to tackle the data imbalance, and also had many experiments on different data splits. If you will multiply all the variants, you will get more than 6,000 combinations to test and evaluate. We always try to deliver the tangible results to the business within the first 4 to 6 weeks. So excluding explore the data analysis, architecture, and infrastructure setup. We had only 3 real weeks for extensive machine learning modeling. And so we have conducted about more than 100 experiments on entire datasets for a dataset of 100,000 images. Each experiment usually have many trials and can take from 15 minutes to 6 hours on a single GPU. By experiment, we mean tracked end-to-end experiment on a cluster. So we're not counting developing runs and experiments in notebook instances. While running one experiment, it was really important to move forward and continue run experimentation for the next hypothesis. So given the fact that data pre-processing took about 5 hours, we had to version output datasets and reuse them in upstream pipelines. Security-wise, we had to minimize an access to the real data, even for machine learning engineers. Most of the full-scale experiments were run in a blind mode, when machine learning engineer works with metrics, reports, and logs without touching in actual images. Yeah, and results-wise, this is the summary of the KPIs that we achieved at the end of this project. So we have improved the recall of original algorithm by 3x. And one of the biggest achievement is the fact that machine learning engineers were focused on the modeling and experimentation rather than fighting with the infrastructure and data preparation. By the way, the final model in this case has been optimized for the iPhone and deployed at the edge device. So the main message here, this could not be possible without proper machine learning toolset on AWS. This is exactly why companies need to invest into a machine learning foundation in order to accelerate AI adoption. All right, the next poll time, can you, we would like to keep this very interactive and ask you many questions, and yeah, please do not hesitate to send a feedback and your additional questions in the GoToWebinar chat window. So how quickly do you launch new machine learning projects in production? Please select one of the following answers. I will not repeat it, you can read it. All right, let's see the results. All right, interesting. Comparing to the previous poll, like 40% of the audience do not have machine learning projects in production. However, okay, thanks for your feedback, and let's move on. So, an overview of AWS machine learning infrastructure. For this section, I would like to hand it off to Alex. So please drive your slides and your introductions.
Sure, thanks. So again, my name is Alex Chung. I'm from AWS, and I think of AWS as really the best place to do machine learning on the cloud. Within our current offerings, we break it down to 3 different layers. We have the bottom, which is our ML frameworks and infrastructure. This is the frameworks that people commonly know for TensorFlow, PyTorch. AWS provides optimizations and releases it within our deep learning containers and deep learning armies, and also available within the SageMaker ecosystem. We have custom chips that are focused on machine learning, such as Inferentia, which is a custom inference module that allows for the lowest cost of inference on the cloud. We also have tools like Elastic Inference, which give you fractional GPU usage to attach to a standard CPU type base instance. Next, above that, we have our ML services, and this really is packaged within our SageMaker ecosystem. Think of this as your own available ML platform where you can build in a notebook or in a Jupyter lab environment through SageMaker Studio, you also have all these other different tools like SageMaker Debugger, where you can actually inspect the tensor states of the model, and you can create alarming to see if your model isn't learning fast enough and stop the job early, or you can do other different things like monitoring the different variables that are fed into a specific workflow job. We also have tools like Autopilot, which reduce the barriers to entry if you are building a analysis workflow on things like churn. And we also have things like first-party algorithms. That's just a few of our features here. And SageMaker holistically has a whole suite of different tools to accelerate your use case. And at the top of the stack, we have our AI services. AI services are essentially tools that are they're designed to mimic a human behavior, so being able to detect fraud or do things like text track, which is pulling in the text out of materials like PDF. It's truly a huge suite of different offerings that ultimately give you as the customer many different options in terms of how you want to build your ML workflows into your existing stack. So we'll focus primarily on SageMaker, and in the next slide, I'll give you a little bit further breakdown in terms of what is available here. So we have SageMaker Ground Truth, which is a way that you can do data labeling. So if you have images or if you have audio or text, you can parse out using a large workforce of data labelers to be able to annotate your data. We have both in-house companies that you can leverage through a platform. You can use your own labelers if you have them on your staff already, or you can use crowdsourced through Mechanical Turk. SageMaker Studio is the Jupyter lab environment that I mentioned before. It gives you all the benefit of Jupyter Hub, but also has our proprietary SageMaker modifications, such as being able to monitor experiment jobs, hyperparameter tuning jobs, and also seeing debugger results. We also have tools like model monitoring, which basically allow you to measure the any tabular data that you have fed into a SageMaker endpoint and detect any of the drift that might occur on your live data against your benchmark original trained data. We have tools like SageMaker Neo that gives you a model compilation. So essentially it decreases the memory footprint and also the CPU or GPU utilization for an identical model without changing the underlying performance. So that's really powerful that we see used on edge devices and also on the cloud. And ultimately, the fact is Amazon is continuing to invest in machine learning because it is an extremely important vertical to help customers reduce their internal costs of building out ML. But we've also figured out a way to serve many different customers because ultimately at the end of the day, we are trying to build solutions that target the use cases that customers have. So if you actually look at our next slide, you can see a lot of many popular names. So ranging from tech startups to large Fortune 500, even Fortune 100 companies. We have a whole swath of different users that have publicly done a reference with SageMaker, and it really is a powerful suite of tools that is used across many different industries, from financial services to tech startups in fintech, all the way down to healthcare and life sciences, to airlines. So once again, we serve a large base, and ultimately the reason why customers are coming to SageMaker is because we have the lowest TCO, so the total cost of ownership. When it comes to the optimizations that we've done for things like our frameworks, we've made modifications to TensorFlow so that it can perform up to 90% more effectively on the cloud. For tools like data labeling, we've made it so that ground truth is far more effective than hiring a third party or building tools in-house for annotating your data. And with our tools like SageMaker Studio and SageMaker Notebooks, it's far more efficient and easy to monitor for your DevOps team and also for your data scientists to launch environments where they can experiment and create new training jobs. And on top of that, we've also done a significant amount of investment into compliance, so SOC 1, 2, and 3, PCI, HIPAA, and the many other standards requirements for different industry verticals. Our goal is to really abstract for you as the customer the undifferentiated heavy lifting that doesn't add value to your core business, and we offer that within SageMaker. And if we were to look at the next slide, specifically in terms of MLOps, if you just complete the whole slide, we offer a suite of different tools here. Most of it's built into SageMaker, but we also have integrations with tools like Kubeflow pipelines. So we have EKS, which is Elastic Kubernetes Service. It provides you a managed control plane for Kubernetes. You can easily set up Kubeflow on top of that. And then once you have that tool installed, we also have additional services that make running open source machine learning workflows easy to do. So we also have ECR, which is similar to the Docker container registry, but we provide it on Amazon, and you can leverage your AWS credentials and account to store containers that you build and track the lineage of them. And between Kubernetes and Kubeflow, we tie them back down to our SageMaker ecosystem through our SageMaker components. Next slide. Through the SageMaker components and also the Kubernetes operators. So if you're a company that has standardized on Kubernetes and have built your own machine learning tools within Kubernetes, a way that you can reduce your maintenance and also take advantage of the latest features that AWS provides is by using the SageMaker operators for Kubernetes. They're a suite of CRDs, so custom resource definitions that you can install, and then you can apply those jobs through a Kubernetes operator. And for customers that are using Kubeflow, we have a SageMaker components for Kubeflow pipelines, which ultimately reduce the total amount of DevOps work that you have to do to build out a production-ready Kubeflow environment. And this ultimately is centered around, next slide, the trends that we've seen in the industry. So within Kubeflow, a very popular repository right now for standardizing machine learning development, Kubeflow pipelines is the package within it that is taking off and has the most adoption so far. And by combining Kubeflow pipelines with SageMaker, you're able to take advantage of both the open source flexibility and portability, while also taking advantage of SageMaker's managed services. So next slide. So all the features that I mentioned before of ground truth labeling, automated model tuning, built-in first-party algorithms like XGBoost, ResNet, etc. Having managed spot training, so you can take advantage of cost optimizations without you having to do the actual gluing together of the code and checkpointing of your models, to scalable inference endpoints and model monitoring. We provide you all these features that complement and also provide managed versions of what Kubeflow offers, with really the ease of only changing a few different definitions within the components that you'll plug into Kubeflow pipelines. And ultimately, because we provide these components within the context of Kubeflow pipelines, you still have the benefit of portability, composing your pipelines in Python and in a notebook environment or CLI or VS Code of your data scientist's preference. You can integrate this easily with your CI/CD tools, and you can create this in a way so that your models that are being created and the artifacts that are outputted are repeatable for either compliance purposes or recreation of new models. And the way that our SageMaker components work is that it can be integrated into a pipeline. This could be mixed with other pipeline steps that you create. So either leveraging a container up, the fully flexible component unit within Kubeflow, or your own custom components that you build off of the Kubeflow Pipelines SDK. So you have full flexibility here of mixing SageMaker components with your own components and code, or you can use a pipeline that's entirely composed of SageMaker components based on what your development workflow requires. And the next slide, I'm going to give you a quick example of this. So this is a pipeline that we actually offer as an example in the Kubeflow Pipelines repo and also on our blogs that take a job off of the CFAR10 dataset. It does hyperparameter tuning of an existing dataset, finds the optimal hyperparameters in the next component, and that is outside of a SageMaker component. So that's running entirely on the Kubernetes cluster. And then from there, it takes the best parameters found and then feeds it into SageMaker training. So you can imagine when you do hyperparameter tuning, you might only want to use a subset of the data to optimize on cost. And then once you find the best hyperparameters, you train on the entire data set. And then the fourth step within this pipeline, you're converting it into a model that can be hosted on a SageMaker endpoint. So essentially taking the TensorFlow artifact and then converting it into an object that SageMaker can load onto an endpoint. And then finally deploying that endpoint on SageMaker. So you can keep in mind that once you deploy an endpoint on SageMaker, we take control of the hosting of it. So all the backend behind the scenes is managed for you. And if there's downtime in an availability zone, we'll automatically transfer it into another availability zone within the region. So this becomes very powerful where you can bring your own container to train the model, or you can bring your own code through bring your own training scripts. And then ultimately SageMaker will handle the deployment of this. So to reiterate, the different features that are on Kubeflow, SageMaker provides you a managed version of all these different services. For companies that are starting out on open source ML tools, this provides you a really quick way to get started. And for large customers that are continuing to grow in their usage, this reduces your total cost of ownership. And within this, just another quick slide on how you integrate these tools together. Next. Yep. When you create your pipelines, it's oftentimes within a Jupyter notebook. So this could be within Kubeflow or within a SageMaker notebook or a SageMaker Studio environment. And once you compose those pipelines using the Kubeflow Pipelines SDK, you can integrate in the SageMaker components, which ultimately will have your execution run on SageMaker rather than on the local Kubernetes clusters. What that means is you don't need to spend as much time on the DevOps work of integrating in the ML configurations onto a Kubernetes cluster, and you can focus more on building new pipelines that solve your core business problem. And to reiterate something I mentioned earlier, we also have our other product on SageMaker operators. SageMaker operators and SageMaker components provide two different use cases. So once again, if you're, next slide, if you're coming from Kubernetes, you would use SageMaker operators. If you're coming from Kubeflow, you would use SageMaker components. Ultimately, for SageMaker operators, if you have a fully custom environment like Flight from Lyft. So we work closely with the Lyft team, and we built an integration of Flight, their open source machine learning orchestration tool, with SageMaker. They were able to leverage our SageMaker operators. SageMaker operators requires inputting YAML. So the Kubernetes CRD job configurations into your Kubernetes cluster, which then launch on SageMaker. This typically is for more advanced teams and companies that have their own proprietary tools or their own unique open source flavor of tools that they're developing. And for the remainder of customers that want open source machine learning orchestration that are using Kubeflow, we offer our SageMaker components. So we'll have a list of getting started materials if you want to try any of these different products on your own. This will be shared in the handout section within this webinar, and I believe we'll also email these out to the registered attendees. And with that, I will hand this back off to Stefan's team, where they'll actually share if you want to leverage SageMaker products in your environment and how to leverage the Provectus team to accelerate development.
Yeah, thank you, Alex. This is pretty cutting edge. So Alex has just introduced the core SageMaker services. Let's see what Provectus brings to the table. What we offer on top of SageMaker and to make it even more practical for you. For those of you who has just joined this webinar, we're focusing on ML infrastructure and ML services. Together with AWS, we have prepared a special fully funded program that we will be talking at the very end of this presentation. This is an image taken from the SageMaker homepage that you've seen in the previous slides. And so first of all, Provectus brings an expertise in SageMaker itself, and also fills all the possible gaps and adds everything that is missing or could be improved in the original SageMaker offering. ML Workflow Orchestrator, the core engine that sticks components of ML pipeline together. From the webinar title, you know we're going to dig into Kubeflow today. And we already done that at some capacity. Data sampling and versioning pipelines, the way you can switch from unbounded stream of production events to immutable, version, tracked, governed, and reusable data sets. A centralized feature store significantly accelerates model development and reduces overhead for feature engineering and the features serving. Advanced monitoring allows you to monitor drift for text or computer vision-based models, as well as to detect not only statistical deviations in your production data, but also catch some complex anomalies. MLOps components for continuous integration and continuous training are also something that we're going to discuss today in more details. Let's jump right into the core concept of reproducible ML pipelines. So we have 4 inputs: the code of your machine learning model, the code that describes your machine learning pipeline steps, and the code that describes your infrastructure and dependencies. Obviously, any code is to be stored and versioned in Git. You also have a fixed, immutable, and versioned dataset as an input for your machine learning pipeline. A dataset is usually sampled from the centralized feature store. You can think about ML Orchestrator as a meta compiler that takes all these 4 inputs and compiles it into the model. As any compiler, it outputs logs, metrics, and alerts, as well as tons of metadata to be stored and analyzed. That's it, very simple. The beauty of this is the fact that it fits into a continuous delivery workflow, as well as into experimentation workflow. You trigger the same pipeline manually to run experiment, and the very same pipeline is automatically triggered from Git hook and CI/CD tools for continuous integration and deployment. So this is the core, a backbone of your machine learning infrastructure and reproducible experimentation and ML operations. Everything else is secondary, in our opinion. Let's summarize characteristics of machine learning pipeline. It is a backbone of your experimentation flow. It is an integral part of your CI/CD flow and continuous retraining workload. Machine learning engineers may run pipelines many times a day to test new hypotheses and debug models. And the pipeline execution should be idempotent. Same inputs should produce the same outputs. It should not have any hidden state or side effects. There are 3 main components ML pipeline is built from: orchestrator, a DAG execution engine, and metadata tracker. The rest of the functionality is handled by integrations with debugger, hyperparameters tuner, TensorBoard, and other tools. Experiments metadata tracker provides metadata store for experiments inputs and outputs, including datasets and models and metrics. It enables implicit documentation for model creation process and transparency for stakeholders. So we can track the progress towards the goal, and we can enable reproducibility, audit, and compliance. There are many alternatives how to implement a backbone of your machine learning pipeline. Fully managed SageMaker service has a component called SageMaker Processing with its own DSL, and there is a SageMaker Experiments that Alex has briefly talked about. There are question marks for SageMaker Processing since its functionality is pretty, I would say, limited in terms of the processing complex DAX, user interface, and integration with the rest of AWS ecosystem. SageMaker Experiments could not be called outside of SageMaker, although there is a data science SDK for step functions and SDK to call SageMaker API. In integration between AWS tools and SageMaker itself is quite limited at this moment. I believe AWS is working on this, and we will see new great things in upcoming releases. And there are always pros and cons in each option. And in this webinar, we're not going to dive into the side-by-side comparison. Please feel free to contact us after the webinar so we can look at closer and at your constraint and considerations. As of June 2020, in our opinion, Kubeflow is the most mature open source project that offers ML pipeline orchestration and metadata tracker, as well as out-of-the-box integrations with many machine learning tools and services. It has amazing community, and AWS has recently started to contribute a lot of integration with AWS native services, so we can offload complex tasks to EMR, SageMaker, or Athena. Let's look at the reference architecture for ML-centric process with Kubeflow. Machine learning engineer continues using well-familiar notebooks for exploratory data analysis. He or she runs data preparation pipelines to prepare a data set for his experiments. It is important that all of the data sets should be generated through the pipeline without manually executed queries, so it is tracked and versioned automatically. Machine learning engineer enables updates the model code, tunes the pipeline configuration, and runs Kubeflow pipeline and observes metrics. The most crucial thing I would like to highlight here is that it does not require extra skills from machine learning engineer and does not require additional overhead for hooking the code into the Kubeflow pipeline steps. Here you can see how pipeline runs are recorded in Kubeflow, so we can compare it side by side. You may notice one of the coolest out-of-the-box feature, ability to start a combined tensor board right from the Kubeflow UI. I think it's pretty cool. So Kubeflow is great, SageMaker is great, and as we've just learned from Alex and from the webinar topic, we can benefit from having two awesome tools complement each other and in a seamless fashion. As a reminder, Kubeflow owns the end-to-end pipeline, its execution and metadata tracking. You can have many purposely built Kubeflow pipelines for data preparation, model training, transfer learning, and others. SageMaker dramatically reduces TCO for managing infrastructure for complex training jobs, batch transform jobs, hyperparameters tunings, as well as offers many additional fully managed instrumentation tools. So using SageMaker components for Kubeflow, we can hook training and hyperparameters tuning steps from your pipelines to be offloaded into SageMaker. Model deployment Kubeflow pipeline can use SageMaker Neo and SageMaker Endpoints API to deploy the final prediction service at the edge or in the cloud. In this particular design, Kubeflow and Kubernetes cluster becomes very tiny and lightweight and uses AWS managed services for heavy lifting. Let's review a reference implementation and architecture for machine learning operation. MLOps, a buzzword that brought you here. We will be using Argo for CI/CD and Kubeflow for ML pipelines. As you may know, Argo is a Kubernetes native workflow engine. Argo CD is a continuous delivery engine built on top of Argo workflows, and it implements a very new and very advanced and very important approach called GitOps. As you may also know, Kubeflow pipelines are also built on top of Argo workflows. So it makes perfect sense to use Argo CD and Kubeflow pipelines all together for end-to-end machine learning MLOps workflow on Kubernetes. In this diagram, experimentation cluster uses version dataset from DVC and executes ML pipeline in Kubeflow, offloading training job to SageMaker. CI process executes the same ML pipeline that has been evaluated during experimentation runs, pushes all the artifacts into container registry, updates infrastructure state repository in Git, and then uses Argo CD to synchronize a Git to synchronize state in Git and actual state in the cloud. Well, this is a cutting edge, guys. Hope you're following me. You're still following me. This is how ML pipelines triggered from by CI hooks recorded in Kubeflow may look like. The same, but just like you basically just separated in different experiment group. Let's wrap up with Kubeflow topic. Here's a summary of best practices for you to take home. Invest into a library of reusable components, just a basic software engineering practices. Use SageMaker components for Kubeflow, discussed a few times during this presentation. EKS, don't need to spend much time managing Kubernetes infrastructure on AWS. Use Argo and Kubeflow. It's opinionated recommendation. There are many other options, so pretty applicable. All other options are pretty applicable for your environment. It's not a hard requirement and hard best practice. Out of the box benefits, you have metadata tracker and pipeline orchestrator well integrated with each other. And the most important is it requires a minimal intervention into existing day-to-day machine learning routines. I hear many times from the data science teams that, hey, I need to change my habits. No, you don't need to change your habits. This is something that you're already doing on a day-to-day basis. It's just like additional value add tool in your X system. It also makes sense to mention a few challenges and things to consider. It is open source project. It is under rapid development. You should expect to have some like incompatible changes as any open source project. It requires Kubernetes expertise. It has just recently got attention from AWS. This is awesome, but I wish we need more. So we've just covered Kubeflow and SageMaker. I would like to briefly cover another very important topic, a feature store. We have 60 minutes webinar, and in this time frame, I can only give you a high-level introduction to feature store, and we can dive more into this topic during a workshop session that I'll talk about at the very end of this webinar. Feature store is a data management layer for machine learning. You know, machine learning models are trained on features, and features are being used in serving time. The main benefit of introducing an additional abstraction layer called feature store is to provide better return on investment from the feature engineering. Imagine you have one data set and many different machine learning applications developed by different machine learning engineers. In this case, 90% of the features are to be reused between those applications. So we will need a way to collaborate and share on features level to avoid forking new raw data sets and accelerate development of new machine learning models. Features could be served in batch mode, in real time, in streaming, or sampling, or sampled for training. All these patterns require different storage layer, and machine learning engineer will not always know the best way how to store and serve the features. So having it decoupled from ML pipeline will increase machine learning engineer productivity and system reliability. Consistency is one of the biggest problems in distributed system, and unified feature store aims to prevent training serving data skew by design. Feature store API is a good place to start tracking your data lineage and data versioning. So all this sounds great, but how can I get started with feature store? The good news here is that properly designed data lake covers almost 80% of system requirements for feature store. In a nutshell, it needs to have the way to ingest data. It should provide a data catalog. It should support API for batch SQL access, and it should have a consistent real-time index for online feature survey. The rest, 20%, is machine learning specifics, API and metadata. The analogy with Kubeflow, why do we need yet another workflow engine? Because it is designed for machine learning pipelines. The same here, why do we need yet another data lake for features? Because it is designed for machine learning experience. Here we go. Let's see what makes feature store different from your generic S3 bucket with 135 different folders, or from general purpose Redshift instance. First of all, it is an API, like get data batch with certain sampling strategy, random read, add or delete a feature. Second, metadata. Lineage metadata, what models have been built from particular feature, profiling metadata, annotation metadata, agreements and judgments, and governance metadata. Everything that enables discoverability and collaboration. This topic is pretty wild in general, and there are just a few implementation options. FIST is an early stage project already included in the Kubeflow toolkit and maintained by Gojek. I would recommend plugging it into existing data lake rather than inventing a separate feature silo. Please follow to GitHub issues I mentioned here. AWS is adding support for AWS native storage and other services. Definitely a good sign. Amundsen is another great open source project by Lyft. For AWS users, you can think about it as a very user-friendly data catalog that complements Glue metadata with search and extensive metadata support. And there's also an option to do it yourself. In Provectus, we've been building feature stores for a while in different capacity. And there are always a lot of tweaks for different data types and workload patterns. Actual implementation might be different for tabular, image, text data, for real-time, and for batch inference. So let's summarize what we've just learned about machine learning infrastructure in general. Modern machine learning infrastructure accelerates time to value for machine learning initiatives and increases trust from the business. So we move from the black box to the very tangible and clear and transparent infrastructure. It eliminates handoff between data scientist and machine learning engineer. I would say more, there is no handoff between data scientist and machine learning engineer. I really encourage everybody to have data scientists to become machine learning engineers and start decomposing your monolithic Jupyter notebooks with thousands and thousands of lines of Python code into very modular and reproducible Kubeflow steps in your machine learning pipeline. It is a must-have requirement for small machine learning shops and for large organizations. It spans from the straightforward image classification projects to more complex ML pipelines. So another myth is, yeah, we're just too small to use this infrastructure. It's not true. It will really accelerate your time to market in any way. It is a must-have requirement for secure and compliant environments. Again, no black boxes. The secure and transparent infrastructure is a must-have. It minimizes growing technical debt in machine learning projects. You can see, like again, in a couple of months, thousands and thousands of lines of code in Jupyter notebooks. I have nothing bad about Jupyter notebooks. It's a great tool for data exploration. However, if you're aiming to launch it in production, you should start decomposing it right away. It and the recommendation is to complement fully managed AWS tools with open source project for pipeline orchestration, experiments tracking, dataset versioning, and feature store. All right, hope you like the content and the value proposition of having machine learning infrastructure. Let's see how you can get started. Provectus and AWS has jointly developed a machine learning infrastructure acceleration program. It starts from a fully funded one-day virtual discovery workshop for a limited number of customers. Please dedicate your time and not money. A bigger picture-wise, a workshop helps you to get started in just a few days. Deliverables include end-to-end solution architecture tailored for your use cases, adoption roadmap, and TCO calculator. Since the workshop is fully funded, we also expect a certain level of commitment and dedication from the customer's management and technical teams. After a workshop, we usually move to a very quickly iteration, basically one sprint from start to finish to get your machine learning pipeline deployed on new machine learning infrastructure. Then we help you to scale and support machine learning infrastructure for other use cases in your enterprise. Yeah, this is a good logo here of fully funded, just to make you remember. Few key days to remember. Then, as for the next steps, you can screenshot this this slide, or you can check it after the webinar in the follow-up email. July 7th, program application ends, and by July 10th we have a qualification calls started, and by July 13th we're going to select 10 customers for the fully funded engagement. Please contact Provectus with the links, share it in a GoToWebinar chat, so and apply for the program. Also, please join our for those of you who is not ready to move forward with the workshop, to commit your time and commit your attention, but would like to stay in touch and ask technical questions, business questions, any type of other follow-ups, please join a Slack channel link, which is posted in a GoToWebinar link. So this is a kind of open community discussion as a follow-up of this webinar, and we're going to post and publish more content on machine learning infrastructure. We will have a machine learning monitoring topic in-depth discussion in upcoming months, and we'll be posting great quick start solutions, and we will be open sourcing some new like integration components and tools that will make you easier to start with the infrastructure I have just described. All right, let's see what questions we have today. See what we have in the question tab in the chat. I see like the people are pretty silent. There's a question Krish is asking, is R supported? Yes, the short answer is yes. The SageMaker, I think it is a separate topic how to bring R on SageMaker and the correspondent articles. We can follow up with the links. In general, especially in SageMaker, you can bring your own container, and you can package. To be honest, I do not remember from the top of my head if there is a predefined runtime in SageMaker for R. But there's definitely a way to bring your own container and include all the dependencies that you would like to support. Okay, good question from Jay. How do you handle data security and connectivity? Is there cell level access to the feature store from Kubernetes? Okay, that's a good question. Let me think a bit about this. So for in AWS, the column and row level security is being enabled by Lake Foundation. This is the project that aims to solve this question, and having the Lake Foundation as a backend for your feature store is the way to solve this. And by using the EKS, and yeah, so that's the answer. We can dive deeper into the kind of the implementation details as a follow-up. So data security. By what do you mean by connectivity? By data connectivity, you mean by data lineage? Data lineage between the kind of what feature is being used by a particular model or different models is being tracked as a hooks and as an additional metadata exposed from the Kubeflow pipelines. So by doing your transformations and recording your transformations and recording this metadata and using this metadata to update your data catalog, so you can, when you open the particular column table or particular column, you can see what are the dependencies there. So it's all ties into the kind of the metadata management and consistency. The question from Ashwin, does Provectus have its own feature store? The answer is we do not have it as a product. We've been building it for a while for different customers, and we do have an expertise in building a feature store, and we have components that could be reused to build a custom feature store tailored for your use case. We're not a product company, we're a solutions and consulting company. Okay. There are a few people. Okay, the question from, oh, so many questions, guys. I keep scrolling it. I love chatting more. I think it's probably good time. Let me take one more question. So the question from Radu, I'm just taking the random question from Radu, and I would be happy to follow up on all other questions. And please do not hesitate to join the Slack channel, so we can follow up as well. Great webinar. I tried to use SageMaker. Could you comment on the cost of processing? Would it be cheaper using EC2, especially for training CPU bound? Thank you. I think Alex can support me on this question. If you will compare pricing side by side, yes, SageMaker adds some margin on top of a vanilla EC2 instance. However, if you will compare the total TCO, the TCO of using SageMaker is much lower than using vanilla EC2 instances. That's the short answer. Alex, please chime in if you have that.
Yeah. So you know, what Stefan said is absolutely correct. If it's somewhat superficial to look only on compute when executives and VPs and of engineering look at their entire spend, it's their staff and headcount combined with their actual expenditures on external resources like their AWS bill. So when you factor in all the different pieces that we are doing under the hood in terms of heavy lifting, we take care of model endpoint creation, we take care of spot checkpointing for training jobs. We also have a different ability to basically abstract away your need for a Kubernetes cluster altogether, because you can run a majority of your jobs from within a SageMaker processing environment. That adds up in terms of what your team no longer needs to do. If you run with SageMaker, you get a lot of other things for free. And that is the benefit of why managed services have become so powerful. If you look at running databases, many people may still run them themselves on premise, but if you're on the cloud, you're going to use a tool like RDS, which provides you a managed MySQL offering because it gives you scalability, performance, auto deployment across multiple availability zones, and also the ability to scale out very quickly with just a few changes to parameters. To do this manually yourself using EC2, it can be done, but is that the most effective use of your engineering resources is time in terms of building value for your business and cost effectiveness? The answer is in our research, no. And we actually have a TCO analysis document. If you reach out to our team here or your account manager at AWS, we can work with you to share some more information. Thank you.
Yeah, thanks, Alex. Yeah, I would briefly take one more question, also randomly, but sorry guys if I kind of haven't chose your question. Ashwin is asking, you mentioned difference in feature store based on data types like images and tabular. Can you expand? Briefly expanding on that. For instance, you can like the tabular data could be stored in Parquet as a storage. But for instance, for the image data, you would need to use the tools like Datastorm. It's a Parquet extension by open source by Uber. For text data, for storing like highly dimensional data, you should also use some like the other tools. The difference starts from this, and also the difference starts from the like latency requirements and the workload requirements. There is no like tool that fits all of the use cases here. All right, we have almost done. I would like to thank everybody for attending this webinar. We will take all of the questions that you have asked, and we will follow up personally with everybody of you. Thank you for being very active, and thanks for joining. What we offer here, we actually offer a collaboration on this topic. You see the topic is very wild and a lot of information, very early stage, integrations, tools, etc. So let's stay in touch, and yeah, thank you. Alex, any closing note from you?
Hey, we just want to thank everyone for their time. AWS is the premier platform to run all of your different machine learning jobs, whether they be workflow, training jobs, or endpoints. We'd love to help you be successful. So if you are in contact with your AWS account manager, please leverage them as a resource. We can get you in touch with solutions architects and ML specialists. And also feel free to reach out to me if I can help with your Kubeflow deployments. We'd be happy to do so. And if we can't help you directly, we can put you in touch with the right team. Thank you all.
Sounds good.